Hey, Vitalik, could you mute your mic?
Sure.
All right, I think we are on. Hi, everybody. All right, so what we're gonna do is, let's see. Oh, Danny, mute your mic too.
Oh,
No problem. All right, we're on the agenda. Yay. The first thing is testing. So, Dimitri, I know you posted an update in the agenda. Do you want to also talk about the update?
Yeah, so we finally started the discussion about this Genesis format, and we have our Genesis scheme, JSON scheme that is checking the formats, and it's declaring how how the fields of Genesis should look like, what are the data and how it should look like if it's a string, if it's required field or not. And from this pull request that I posted in that link, we could now move on and come to a better understanding of what we want from this general Genesis format. So I advise everybody to read that link and discussion on test repository.
Okay, awesome. Is CPP Ethereum the only Ethereum client that's implementing these new testing features right now?
All right, and I'm like the only one person working on that.
Okay. Talk to me after about getting more help on that. I think we had a thread going around about that if you're not involved in it. I think you're in the thread though.
Which type of
Email. It was an email thread about getting more help on the testing side.
Yeah, I remember something. I don't remember where.
Okay, I'll resend it to you. No problem. Thanks for the update.
Okay.
All right, now we're on to client updates. Let's start with Geth and Peter.
Ew. Sorry, had a hard time finding the unmute button.
No problem.
So regarding client updates, I don't think we have anything too spectacular. We are focusing mostly on performance. We released, basically our previous release was last week, which is kind of give or take 20-30% faster and lighter than the previous ones. We still have a lot of ideas that we're currently benchmarking and trying to implement. I think that's the only meaningful update I can give you now.
Okay, cool. Parody.
No real update here either. Just wanted to say thank you to everyone involved in the recent issue and helping it get it fixed so quickly.
You're welcome. Well, I mean, I didn't do.
Congrats on that smooth rollout.
Oh yeah, definitely. That was super smooth. And I said you're welcome like I did anything, but I did not fix the bug at all. Just to be clear, everyone did a really great job. All right. Next we'll have Harmony Ethereum J.
We just released, and this release I have mentioned before is about RocksDB tuning and some memory improvements. We also have planned a new one, so it's good that we starting to have some time for planning and some project micromanagement or yeah, and we plan to start to work on that release during next week. And we also plan to update our Casper implementation according to latest changes in the EIP on the next week and try it in a parity test network. So here are all updates, I guess. Thanks.
Oh, thank you. Next we have. Is anyone here for CPP Ethereum? If not, we can just skip that one.
Me.
Oh, there we are, Dimitri. Sorry. Go ahead.
So from my changes, I already posted. Like I have a branch, a testing branch that is a work in process. It's a modification to existing CPP client on which I run the test via this RPC methods. And yeah, I have a success on execution of state tests. State tests work like really fine, but well, timing is not exactly like it takes 10 minutes to execute all of the tests, but it's mostly because the CPP code base is not optimized to run the RPC requests, and that some optimization required to CPP client. And I also did research, and the state test could be generated via RPC into blockchain test, and blockchain test could be executed without mining, without proof of work check. But well, the main stopper for me is that CPP client is not ready, is not optimized. Also, Andrei is working on CPP client optimization and improvements. He did like many pull requests I see from him, is coming from him. But well, he could say better what his work.
Okay.
So that's it.
Okay, great. Trinity.
Yeah, so we pushed out our first alpha. I guess that was like a week and a half, 2 weeks ago, and we're
Yay!
yeah, it's exciting. And we had somebody fully sync, and they synced onto the Ethereum Classic chain, so we had a bug to fix.
Out.
So anyways, we're working on a bunch of performance fixes and things like that, as well as just like bug fixes. A lot of scrambling right now. Looking to put out another kind of named release next week with a lot of new fixes in it. So turning away.
Piper, when you said somebody managed to sync, is this light sync or fast sync?
This is fast sync. So yeah.
And do you have any numbers on it? I'd be really curious.
I think it took close to 4, maybe 3.5 or 4 days, and that didn't include the actual state sync. It blew up once the once we got to syncing the state, due to the being on the classic chain.
Yeah. Okay. Thank you. Just curious.
It's great that you sync to the one true Ethereum chain instead of this other chain. So at least there's that. What's next? Pegasus. Is anyone there for that? Daniel, or do you have any updates on the consensus end of things? Hello, Daniel. I think you're muted.
Oh, sorry, I was muted. No updates from me at the moment, though I don't represent Pegasus.
Okay. Oh yeah, I always get that conflated.
That's okay.
Yeah. Is anyone here from Nimbus or Ethereum or Mana? I didn't really think so. Guillaume's here, so let's go ahead and get a Whisper update, if you don't mind, Guillaume.
Sure. Well, actually, last week I was working on EWASM. Oh, sorry, this week. But Whisper we released V6 some time ago. We're just working. Like right now, I'm working on an experiment to get libp2p to work with Whisper. The goal is to see if we can teach devp2p in the medium term. So it's more of an experiment platform at the moment. And yes, over the summer I'm going to participate, with the help of Martin. I'm going to create to have an audit, a security audit of Whisper, update the documentation, and the release will be over. I think, or will be complete. Sorry.
Awesome, great update. And last but not least, TurboGeth.
Hello, it's Alexei here. So I have posted some update a couple of days ago, but I just want to say that my one of the latest version is still syncing. I think it's about syncing about 5 days, and it's currently on the block 5.07. And this is actually the sort of the archive mode, which preserves the entire history. And it's currently, the database size is about 210 gigabytes, which is pretty cool. I mean, I will be able to get it down even more, So I think at this point, I'm pretty. I mean, I'm not satisfied with the performance, but actually, I'm going to stop here, and I'm going to try to prepare for the release, which is currently what I'm working on is this thing called ETH tester. The idea is that I realized that the way that currently the implementations are tested are like with the test that Dmitry is working on are actually they tested indirectly via CPP Ethereum client by putting them into these what is it called, the Hive. So there isn't actually direct tests on like this kind of test onto all the clients, and this is a bit of a shame. So and also I didn't find adequate tests for the reorg. So that's why I'm writing this tool, which will be able to communicate with a node using this peer-to-peer protocol and be able to basically feed whatever blocks it wants, cause the reorgs of the arbitrary ways, and hopefully maybe I will be able to get some state tests there as well, but I'm not sure yet about this. Yeah, that's my goal. And then after that, if I succeed doing this, I will just clean up some RPC implementation, and I think I'm going to do the first release. That's it for me.
It sounds like you're working in exactly the same thing that I do.
Well, yes, but it's in a slightly different way. So I did review your the tested and retested, and the way that you do it is via RPC interface, which will have to be implemented in every client. But I'm trying to do it in a way that does not require any changes in existing clients. So basically, do the same test but without any changes. So you're gonna just take any client and test it. Regardless of whether they have this RPC. But I'm not
Yes.
sure if I will succeed.
Well,
but
well, it is still the same thing because my goal was to not like introduce new RPC methods by if
yeah,
you
okay, yes, definitely. So
export this like if you find a way to implement those methods without introducing new ones, like I need to get some information from the clients, like the block raw data, the transaction raw data, and I need
right. Yeah, I have you on Skype, so we will keep talking about it. Yeah.
Yeah, well, let's talk about it.
Okay, cool.
Alexei,
Yes?
out of curiosity, which instance do you use to run?
What do you mean, which instance?
I mean the machine which
Oh, okay. So I run my test on two types of machines. They're both in Google Cloud. So the specification is 4 CPUs. I'm not sure the model of CPUs. 26 gigabyte of memory, and one of them has SSD. I think 500 gigabytes of SSD. Another one has 500 gigabytes of HDD, and I kind of compare them with each other. That's it. And currently the memory consumption actually fixed it after ETCON. It doesn't consume more than 6 gigs of memory in terms of the heap allocation. It probably does consume more in terms of because it uses memory mapped files. So I assume that the operating system actually uses more, but in terms of Go heap, it doesn't go above 6 gigabytes.
Okay, and I guess those 5 days is on SSD, right?
Yeah, the thing that I just said to you, it's an SSD. So the HDD is falling behind, but not too much. So in my blog post, you could see the graphs that HDD is falling behind, but it's still plausible to do that. When they both sort of sync to the end, I will publish another updated comparison for everybody to see. And I also published the disk breakdown because of the database I'm using. It's very easy to break down like what exactly is consuming this 210 gigabytes. Like what is the account storage, what is the contract storage, what is the pre-images, what is the receipts and stuff like that. So I will publish that too quite soon. Well, in a few days when I finish syncing.
Okay, thank you.
Okay, thanks for the update, Alexei.
Hey Hudson, just here Raul from Prismatic Labs. I was wondering if I could give a quick update on sharding client.
Yep. You were the
hey
next.
guys,
You were the next one up. Feel free to go.
Okay, great. Hey guys, Raul, working here on sharding implementation for Geth. Just wanted to give a quick update on where we are now. So we have essentially finished the minimal sharding protocol implementation. Currently have proposers and notaries performing the responsibilities, interacting with the sharding manager contract, and have implemented this using similar models as Geth does, and making sure that we're extensible with their interfaces. Aside from that, we're holding off a little bit on the latest research on kind of random beacon chains and dynamic shard count properties that have been worked on in Eth research, just because those things are currently in flux, and we're trying to basically be as scrappy and as efficient as possible. Our first release will basically involve kind of a containerized system where we have, anyone can download this, can clone the repo, run like maybe a Docker or a Kubernetes config, and see like proposers, notaries, all performing the responsibilities, and kind of observing the state of the shard network on your local computer. So it'll be more of a proof of concept release. And that's essentially where we are right now. Also exploring peer-to-peer networking through GoLib P2P. And that's also something that's in flux with the research. So at the moment, we're just trying to get something that works and is aligned with the current spec that's out there.
That sounds great. Yeah, so, and I guess later when it makes sense, I will talk a bit about like some of our latest beacon chain and shard research, which does change the kind of roadmap around fairly significantly, especially factoring Casper in. But I mean, like I do think that like all of that still is work that's basically kind of on the same track. So have you done anything regarding like sharding the peer-to-peer network, or is everything so far still being gossiped through the same net?
Yeah, it's all being gossiped at the moment, and essentially, we're mostly focused around the workflow of just the proposers and the notaries interacting with each other, thinking about sync of shard chain data, and we still haven't really figured out reorgs. So that's something that we're going to be working on next. Yeah, aside from that, we're trying to not do anything that will be extremely disrupted by changes on the research side.
Okay, no, I mean that's still really great progress. Thank you.
Cool.
All right, awesome. So what we'll probably do now is we'll go EWASM, because we're kind of in the research / client / whatever section. So EWASM, then KEVM, and whatever else Everett is working on, and then we'll do Vitalik and his update with Danny and Justin and whoever else wants to give part of that update. So for EWASM, Casey, did you want to give an update?
Yeah, sure. Mostly we've been focused on making a block explorer that's EWASM friendly for the impending testnet launch. And also Jake has been working on an abstraction around Hera so we can swap out Binarian, which is a WASM interpreter, for WAVM, which is a JIT engine. So it should be faster than parity if we can do that.
Yeah, right now I'm working on integrating WAVM specifically, as well as a benchmarking module for Hera, so that we can test performance of, well, different interpreters and JITs, as well as certain bytecode that can cause the JIT to take much more time to compile.
Yeah, JIT bombs. We're not so worried about those for the testnet launch. We'll just let people blow it up if they figure out how.
Nice. That's a good way to do it. All right. Now Everett, if you're on and want to give any updates on, I think you might be working on KWASM now. I actually haven't kept up.
Yeah, I haven't been attending the meetings. Can you guys hear me?
Yeah, I can hear you great.
Awesome. Yeah, so kind of in parallel with the other EWASM work around just infrastructure you need for a test net, we've also been having discussions about just kind of more the technical side of how we're going to integrate EVM and EWASM together on a single blockchain. And I'm not super familiar with the sharding plans, but basically the approach I've taken is to kind of try to allow as much flexibility on the K specification side as possible. So basically I've taken all of the blockchain level kind of update functions or opcodes that you get in EVM. So these are like the call opcodes and the create opcodes and things like block hash, which queries something about the blockchain state. And I've pulled them out into their own file that we're calling the KEEI for Ethereum environment interface. And they essentially just define the abstract updates that have to happen on the blockchain side or queries that have to happen through the blockchain to implement those, particular pieces of functionality. And then K allows you to kind of take two K definitions and mash them together. So then I'm going to take KEVM and remove that functionality from KEVM and then just mash it together with the existing functionality and then make sure the resulting thing still passes the test, basically. And then once that thing passes the tests, then it should be fairly straightforward to take the KEI and mash it together with KWASM and get a model of, KEWASM. And yeah, and there's been a lot of discussion about what the EEI is. To me, it just seems like, a bunch of abstract, state changes that you can trigger on the blockchain from the VM, and the VM should only handle execution level details. So the VM for EVM is just, the stack, the word stack, and the local memory, and pretty much nothing else. So things like add fall completely within the VM fragment and not at all on the EEI side, whereas something like self-destruct, falls on the EEI side. Another thing that's come up is, there's some kind of sticky opcodes with EVM, like call code, and just kind of historically not great things, and we'd like to limit their use in EWASM. So we're thinking, it'd be nice to say, okay, there's this set of abstract state update functions that clients can implement for the Ethereum blockchain, and the each different VM, each different execution engine, like EWASM, for instance, can choose which subset of that it actually exposes to contract. So right now, the subset is just the entire thing, and it's all exposed to EVM. But we're thinking, for instance, okay, we'll break self-destruct into two operations. One which is just a self-destruct, all it does is destroy the account. Another which is just a transfer funds. And I've heard arguments against transfer funds primitive that I honestly don't, it doesn't make sense to me, because you can already transfer funds. It's just you have to kind of jump through this create/self-destruct loop instead to do it. So I think we should just have a primitive for it. And maybe we can, expose that primitive, the transfer funds primitive, to EWASM, but the EVM, whenever it calls self-destruct, it always has to call both self-destruct and transfer funds at the EEI level to maintain backwards compatibility. So sorry, that was probably a lot, but does the overall idea make sense?
Sounds good to me. I obviously wouldn't understand it, but it sounds like there's a lot of good progress being made.
Yeah, it's mostly just been a lot of discussions, and then we have occasional updates to the EEI spec, which is at EWASM/design, and it probably should be moved to something more like Ethereum/EEI, but we'll just develop it for now and then work on it later to move it.
Okay, great. Thanks for the update. And then we have Vitalik, and Danny and Justin are on to give any further things besides Vitalik if he needs.
Mm-hmm. Yeah. So do we want to start talk about our kind of Casper and sharding updates now?
Yeah, absolutely. You're on.
Okay, great. So let's see. There's one major link that I want to send, but I'm going to push it into the Skype channel first, and then maybe send it over. Hold on. There we go. It's a notes.ethereum.org link. Do you see it?
Let me look real quick.
It's in the Allcore Dev Skype.
Oh, yep, I see it. Do you want that to be public, or will it crash it?
I don't.
Crash it. We can move it to a gist if it crashes.
Okay.
Okay.
So the basic idea here is that this is a sort of substantial reworking of intermediate steps in the roadmap, though not the final product. And the main kind of material difference is, so what this specification says is that it is a beacon chain that basically is a proof of stake chain that kind of hangs off of, so you can sort of call it a side chain of the main chain. And this beacon chain implements Casper FFG validation, so it implements like voting, justifying, finalizing, in the same way that Casper FFG did, essentially, though with some simplifications. It also implements basic kind of shard management, though there are some parts of shard management that are currently sort of not specified here, and that's in part because like it's in part because we want to sort of preserve optionality about how those parts evolve over time. The significant difference is that this kind of roadmap would basically involve mean that for the hybrid Casper FFG part, basically we just end up not going with the version that had Casper FFG as a contract on the Ethereum main chain. And instead, like basically, if we want to deploy hybrid proof of stake as a kind of prelude to full proof of stake and sharding, then what we can do is we can just run the beacon chain. And because this beacon chain kind of implicitly links to the main chain, it can be used to finalize the main chain, but it does so without being sort of directly inside the main chain. So the key thing that this would mean is that like the only contract written in Viper or written in whatever that would exist at any point in the roadmap is basically a contract that allows you to call a function to send 32 ETH along with some arguments. It would burn the 32 ETH and it would create a log. And everything else would be processed by the rest of the system. So I'll stress again that like the functionality that this provides is basically, like at least in the short term, is basically like very similar to the functionality that Casper FFG as a contract had, with an exception that like this particular mechanism is one way, right? So it basically means that if someone deposits 32 ETH into this contract, then that 32 ETH is basically just in there until a future hard fork implements the part that allows that 32 ETH to get withdrawn into a shard, and where the shard state transition function is more fully enabled. So basically, the main advantages of this are one, that even the kind of the Casper components is somewhat more separate from the main chain, which basically means that it can be developed kind of more less intrusively in some ways. So basically, it can be developed as a separate chain, and it can have its own rules about how vote messages are passed around the network, how blocks are passed around the network, how blocks are included, and you don't really have to worry about like interactions between Casper related transactions and not Casper related transactions, and like what gets processed in parallel and what's not, and so forth, because there's a much clearer wall between the two systems. So what the beacon chain does is also, the beacon chain is essentially a full proof of stake chain. So the beacon chain has a proof of stake based block proposal mechanism, but every block in the full proof of stake chain also references a block in the main chain. So that's the sense in which the full proof of stake chain kind of hangs off the main chain. And so if the proof of stake chain finalizes itself, then whatever proof of stake block gets finalized points to a main chain block. And so like that kind of gets indirectly confirmed by the proof of stake system. So other benefits of this are that like basically it removes the need to develop a lot of infrastructure around two kind of completely separate proof of stake games, where you have one which is the Casper game and proof of stake game, and the other is the sharding proof of stake game, because here there will basically be only one validator set, only one way to get into the validator set, only one kind of validator right from the start. And basically with and also the actual development of the one system will be much more directly kind of en route to the development of the of what we expect the sort of final later stage sharding system to look like, right? So basically the idea would be that this beacon chain would once so basically once the beacon chain is fully operating, once there's a substantial number of deposits on it, once the sharding part is enabled, once the shard state transition function is enabled, then that beacon chain basically is would already be the main chain of the sharding system. And the kind of basically like you would not, there wouldn't really need to be that much work that would needs to be kind of redone all over again in order to move from the kind of partially done Casper step to the full Casper and sharding. That I linked kind of spec, so it describes, you know, basically what the blocks in the beacon chain are, what the fields in the beacon chain are, what the state is. It includes the different parts that the state are split into. It describes the fortress rule. It describes the state transition function. There is also a partial Python implementation that implements I mean, it's somewhat outdated now, but it implements most of the core logic. And you know, I believe Danny has his own private fork that's even more advanced at this point. So another important feature of this is that this particular, you might notice that in the proof of stake, in this particular proof of stake chain, the proof of stake deposit size reduces from a minimum of 1,500 ETH to exactly 32 ETH. Basically because by in the short term using BLS signatures for basically signature aggregation, which has the property that if you have, say, like a fairly large number, even 1,000 validators that sign the same message, then in order to, like, all of those signatures can be combined into one signature. And in order to verify that signature, you basically need just one signature verification operation plus one elliptic curve addition for every participant. And there's about 1,000 elliptic curve additions in a regular signature verification, so the cost of an elliptic curve addition is fairly tiny. So and that's in the short term. And as far as the goal of wanting to have something that's kind of quantum proof and ideally kind of purely hash based in the long term, we are simultaneously exploring, like, basically in the long term replacing the BLS based system with Starks. And like, there's reason to believe that if we use the right hash function, then using Starks to verify aggregate signature may not be that bad either once the tech is developed a bit more. So I guess, like, just to kind of like re-summarize all of this, the intention is that basically this is both like roughly the current direction for the sharding roadmap, and also essentially a replacement for the Casper FFG roadmap. And now it does keep the algorithm for Casper FFG basically in the same way as people, like, in terms of like what people vote for, like justification, finalization, like dynasty changes and so forth, roughly as it already is. But it does mean that it gets implemented like basically in native code instead of being implemented in Viper. And this had basically what this, but at the same time, this beacon chain is also something that pushes us much further along the way toward a kind of final product sharded system. And we get, because of like things being written natively and kind of optimizations involving bit masks that aren't really available in the EVM, as well as signature aggregation, this design can like basically scale up to, well, the theoretical maximum, which is like assuming 10 million ETH participating in about 300,000 validators, and it can likely even survive in the absolute practical max, which is 4 million validators, which is basically absolutely everyone participating. And like there's numbers for why it basically like it could work fine, even like it could work even under those conditions, which is and I'll basically point to and like basically the kind of worst case behavior and even the average case behavior is substantially more feasible than it was under the old roadmap. One of the main things that we lose from this are basically, number one, the ability to deposit into Casper and then withdraw from Casper without future hard forks. If that's really desired, then it's possible to, I guess, potentially put some kind of gadget where basically the contract can verify some BLS aggregate signature and vote to approve withdrawals, but like that's still decided whether or not. And there's obviously different perspectives about whether or not that makes sense. And the other major weakness is that unfortunately this does lose signature abstraction, though one thing that it does, though arguably it does somewhat reduce the need for some of the fancier schemes, basically because the minimum staking amount goes down from 1,032 ETH, and so just regular individuals participating in staking directly becomes more viable. I don't know, Danny or Justin, do you have any? Is there anything that I missed, or you think I should say more of, or you want to say?
I think you covered most of it. To be clear, we're saying we're going to deprecate EIP 1011 in favor of this new design. This is something we've been talking about for a couple of months now, and something that, as someone who's been working a lot on this Casper contract, it took a second to kind of digest and be comfortable moving forward. But I am totally in favor of this. I think this is the way to go, and I think it gets us where we want to be sooner rather than later.
Hey guys, could you talk a little bit about the proposal of shard blocks? I know you mentioned in the doc, Vitalik, that in an initial release, like you can make the crosslinks be the Merkle roots of blobs of data. So
Yeah.
could you talk more about the roles of proposers in the system, how you envision that moving forward?
Sure, that's a very good question. So what I use the word crosslink a lot, right? So to kind of define the term very clearly, the basic way that like this category of designs works is that you have like a separate chain for every shard, and these chains are kind of progressing on their own in parallel. And once in a while, some particular block from every shard would basically be attested to by a randomly sampled committee of validators on the main chain. So basically on the main chain, some like randomly sampled committee of validators would come together and say, we've all verified like the portion of the shard chain after the since the last crosslink up until this block. We think it's all correct. And here's the hash of a block, and here look, we've all signed it. This aggregate signature would get published to the main chain and verified on the main chain, and then that basically updates to being the main chain's current view of what the latest block on that particular shard is. Right. So the long-term vision here is that you can basically imagine that, like, if let's say on average we have one block appearing in the beacon chain, say every 5 seconds, then one epoch would happen every 500 seconds, which is about every 8 minutes, which once again is down from the previous epoch length we were thinking about, which was I believe something like 15 minutes, and basically every epoch, there would be a crosslink made from some number of shards. So if 10% of of all the validators are deposited, it would be from 10% of all the shards. And so you could see that, like, say, any given shard would have a new crosslink that gets added to the main chain once every hour. And I mean, if we want, we could always like crank up the number of crosslinks at some cost to the efficiency of the system, or just increasing overhead. Like generally, like basically, the crosslinks might happen something like once every hour for a shard, and then but even in between crosslinks, you can generally trust the chain to have like the shard chain's own growth to be fairly good at kind of not reverting in the short range. So if a block even gets like 2 or 3 confirmations in one of the shard chains, that's already a pretty good level of security. But that's kind of a long-term goal. The short, if we want to be lazy, so if we want to just say, we want quadratic sharding out the door as fast as possible, and we don't care about 1 hour block times, we just want the 5,000, like 5 to 10,000 TPS already, goddammit, then the strategy that we could take is basically, instead of crosslinks like referring to a shard chain, crosslinks are basically just blobs that are connected to a shard, and there's some proposer that's assigned to a shard, where that proposer is the one that would basically have the ability to create a crosslink, right? So one of the things that's not yet listed in this document is the exact rules by which proposers would be selected. But generally, what would happen is that every validator would be randomly assigned to some shard for a fairly long period of time to be a proposer, and then in this very naive, simplified design, like basically every time a crosslink is created, some new proposer would get selected, and that new proposer would have the ability to propose the next crosslink. But in the longer term model, like basically the set of proposers in that shard would kind of between themselves end up creating and pushing forward the chain until some block in the chain would get would get included in a crosslink. And these two perspectives are kind of equivalent to each other in some sense, basically because you can view the version where a crosslink is a block of a chain as being a version of the proposal where a crosslink is a pointer to a blob, where the chain is basically just a device that the shard proposers use to coordinate amongst all of each other themselves which blob to push for inclusion as a crosslink. So like basically the long-term goal is that crosslinks are just this way of like linking between from shard chains to the main chain. And if we want to do something shorter term that's lazier, then we can just say that crosslinks are pointers to blobs of data that are proposed to a particular proposer that was assigned to some shard for some fairly long period of time.
So I guess as far as like before, we were kind of thinking that it would be like Casper released and sharding released, but maybe close together. This is kind of combining them into Casper sharding, right? To make it like super simple. Okay.
I mean, even though the design is merged, it is definitely possible from a release standpoint for one to come before the other. So for example, it's possible for Casper to come before sharding, even though they would both live in the beacon chain. And actually, I'd say that's more likely to happen, that Casper comes before sharding at this point. In terms of other bits and pieces that I wanted to share, one of the kind of advantages of this is also, moving away from having Casper FFG in the current Ethereum 1.0 chain is more security, and that's kind of a consequence of the one-way deposit. So it's not possible to do withdrawals until there is state in the shards, and that means that effectively the deposits will be frozen for quite some time, and it means we can kind of launch with more confidence and potentially experiment and move faster. Another thing is because it's all native code in the beacon chain, no EVM, there's going to be some simplification. So we don't have to worry about gas. We don't have to worry about gas limits. And it's also more future-proof because the kind of the end goal, the end game of Ethereum is effectively to deprecate EVM 1.0 as we know it. And it's also more future-proof, as Vitalik said, because it's much closer to the final design. Another thing it does is that it allows to unlock new functionality, and especially the BLS signature stuff, which kind of radically changes the performance properties of the design. Another advantage, or kind of a nice thing to have, is that the beacon chain will have possibly 5-second blocks, so faster blocks and less variance. Another thing is that in general, there'll be more unity between the Casper and Sharding and the teams developing these two projects. So I think that's good, more network effects there. Another thing to mention maybe is that, Vitalik already said it, that there's going to be a lot of reused capital, infrastructure between
Nick, could you mute your mic?
Between Casper and Sharding, all the way from the capital that is deposited, the 32 ETHs, all the way down to messages, gossip channels, signatures, coordination points, aggregation mechanisms, accounting. And kind of from a high level, I'd say that large parts of Casper actually come for free if you're given sharding. So large parts of Casper are kind of a subset of the infrastructure that we want to build out for sharding. So that's kind of nice. And another kind of point is that once we start merging the validator roles of Casper and sharding, then we also potentially get better security. And the reason is that we can have atomicity of the roles. You can't be a Casper validator without being a sharding validator, or vice versa. And it means that if for some reason we mess up the incentives in such a way that it's for example very profitable to be a Casper validator, but being a sharding validator is not so great because you have to do all this work and you don't get much income from it. Well, tough luck. If you want to be one, you have to be the other. So that's kind of nice. In terms of my final update on the sharding thing. There's this recent idea of 1-bit custody bonds, and these are really, really cool. I just wanted to give an update. So basically, in sharding, you have validators voting on the availability of some piece of data, like a shard block, and we can have an honesty assumption, and we can trust the votes that are being made. Or what we can do is we can have this idea of a custody bond, which is that when you make a vote, there's some sort of cryptoeconomic scheme which highly incentivizes you to actually have custody of the data for which you're voting availability for. And one of the recent discoveries is that basically we can have this enhanced voting mechanism where the validator most likely has custody of the data at basically the same cost of making a plain vote with a signature. And it all works really nicely with the BLS aggregation.
Okay, cool. Thanks for that. I think we're good on the research updates, unless there's anything final. Okay, great. And then Vitalik, if you can mute.
Oh, sure.
The next thing on the agenda is net gas metering for S-Store operations. Nick, is that yours, or was yours a different one?
That's mine.
Oh, go right ahead then. Because there's been some discussion in the agenda about it as well.
Okay. So, the basic idea for anyone who isn't familiar is that we have a bunch of cases already where a contract execution would result in making changes to a storage value and then changing it back. So the net change is none. An example of this would be using authorizations in ERC20 tokens. if a contract wants to authorize another contract and then revoke it afterward after the operation's complete. And a bunch of other cases where it'd be useful to be able to do this, but it's cost prohibitive because of the cost of S stores. So this EAP proposes to change how S store and S load are charged for, so that you're charged in the end based on the changes you actually need made that need to be persisted to disk. So multiple writes to the same value only get charged once, and if you reset it to its original value, then you don't even get charged for that, except for the read cost. So the idea here is to improve the usefulness of S-Store and also reduce excessive gas costs for operations that actually aren't as expensive as they're being charged for at the moment.
Okay. Anybody have any opinions on that? That's going to be one of the things we talk about as a possibility for Constantinople. And just so I'm making sure, Nick, this is something that would go into a hard fork, right?
Yes, absolutely. And yeah, I would love to see it included for Constantinople. I think it's relatively straightforward and it would make a whole bunch of use cases available now.
Cool. All right, anybody have a comment?
I think the EIP makes sense. It's nice, easy, shouldn't have an impact on performance.
Yeah, I would like to make a comment. We need to come to an agreement which changes would be included in the next hard fork as soon as possible, because we need time to prepare the test.
That's a good thing to say, Dimitri. I agree. And I think that we are going to try to do that over the next few weeks if we decide that we want Constantinople to be happening before the end of the year. So actually, let's go ahead and skip Skinny Create 2 and EIP 210 and just talk about Constantinople for a second. And then we'll get back to those since those are in the list of potential EIPs for the hard fork. We've gone back and forth about when to do Constantinople, and I'm kind of just wanting to hear what everyone's thoughts are about maybe doing it before the end of the year, or as soon as possible, either one, because we don't have a timeline for some of the research ones that we might want to bundle into a huge hard fork. I think it would be prudent to talk about anyone's opinions if they want to have it in this year.
Given the recent report from the Casper team, it seems less likely that we will have anything Casper related ready to go in the original timeline, in which case Constantinople should maybe be dedicated to improvements that we have queued up and wanting to go unrelated to that.
It seems sensible.
Yeah, I agree.
Yeah, and it looks like we have enough EIPs now to justify a hard fork, because before we were just on bitwise shifting and block hash refactoring, and now we have a few other things that, like Skinny Create 2, that we might want to go in there and stuff like that. Of course, keeping in mind that there will take a lot of time for testing, and we're not going to rush anything like we've done in previous forks that needed to be rushed because of emergency situations and the like. So any other comments on timing of Constantinople? Otherwise, I'll throw out some suggestions.
Before or after DevCon?
That's a good suggestion. Anybody else?
Oh, I just mean, last year, I think there was a fork kind of soon before DevCon, and people were concerned about that because if something bad happened, then we were all at DevCon. But the counter to that was if it was after DevCon, people might have much work through DevCon. So just something to keep in mind as we plan this. And I know we don't even know which ones are going in, but let's just not put ourselves in some weird predicament around DevCon.
Yeah, so it's the middle of June right now. It is 1, 2, 3, 4, 5, about 5 months till DevCon, something around that area. So I think we can do a hard fork in less than 5 months. Does that sound right for the amount of EIPs we may have going in, which would be about 3 or 4 of different varying levels of difficulty?
Yeah, I think the EIPs themselves are fairly straightforward, so the bottleneck would probably be testing here.
So if we agree with that, would it make sense to devote a section of the next all core devs to considering all the proposals and approving them or not?
Absolutely. What we'll probably do is this time we're going to go over them just to make sure it's on everybody's radar, and then next time we'll do approvals or non-approvals just to make things quick. Oh, sorry, just a second. Ow. The cat just clawed me. Alright, I think I'm good now. So with that, what we'll do is the next call, we'll try to get a little bit more detail on which ones are going to be approved. For now, let's just go over some of the ones that might go in. EIP 145 bitwise shifting, we already talked about how it's well formed. It's not 100% implemented or tested, but it's one that we've agreed on in the past. Does anyone have any dissenting opinion on that or any comments on including it?
Yeah, test coverage for bitwise shifting should be pretty easy. It's just state test transitions, and it's nothing that we don't have. I think we have unit test for bitwise already implemented, and I could make blockchain test out of it.
Wonderful. EIP 210 block hash refactoring. That's another one that I think we already said we want to go in. Anybody remember if we said that or not?
In my last I saw, there was still some questions about the robustness of the block hash refactoring code and whether it should be, well, refactored. So I think it's probably a good idea to include it if we can, but we need to knuckle down and figure out exactly how it's going to function.
Yeah, actually, if you look at item 6, I forgot about this. I put in item 6 some of the concerns that Martin Holzvende had. Specifically, to clarify, is 210 Vitalics? Let me look real quick. Yeah, this is Vitalics. So, I guess clarifying that it does not change the current semantics when invoked via block hash, so it doesn't deliver older blocks. Do you have any comments on some of the concerns listed in the agenda, Vitalik?
Let me look up what the.
Oh, you just cut out. Are you there?
I'm here, yes.
Wonderful. You said you're going to look it up in a second?
Yeah, let's see. Wouldn't it make sense to rewrite it using the new shift opcodes? Is the gas consumption counted? Right. When we do the opcode call transition, the cost is 800 gas, but in the call context, we suddenly have 1 million gases. Yeah, the 1 million is definitely something that should not be fitting. That should exist regardless of like block gas limits. And like I guess the other thing worth pointing out is that clients don't have to implement it by making the opcode be a call. Like it's just an alternative way of implementing it.
Okay. Is this something that you could work on as far as updating it to some of the latest things we've
Sure.
talked about? Yeah. And also just reference item 6 on the agenda for some of the questions that Martin had specifically. They're also listed in the agenda comments. Wonderful. So if we can get that sorted out, we can put EIP 210 in if we want. The next one on the list is account abstraction. I think we tabled that pretty much permanently because it was too complicated. Is that something that's needed for any future researchy things that we would need to put in?
I think the main kind of the main thing in the abstraction category that's really valuable for people in the here and now is the skinny create 2, because that does make state channels in particular much easier.
Agreed. I'd really like to see that.
So what we can do is, instead of doing account abstraction, we can just do skinny create 2. They can be separate, right?
Yeah, totally.
Okay. In that case, we'll table account abstraction. I'll leave it in the list for now, but I don't think anyone's advocating for it. Is anybody? No? Okay. The next one, ext code hash. Is that one that we said that was going to be in there? I basically looked through old notes and saw that this was one that Nick brought up and that we talked about. That would be pretty cool. Nick, do you want to go through and just do a quick paragraph explainer?
Sure. I mean, basically, the idea is we currently have a way to fetch code, but although we already have the pre-computed code hash, there's no efficient way to fetch that inside the VM. And there are a bunch of situations where it's useful to be able to do so, and there's no reason it should cost as much as it does. So this is just a suggestion to add a very simple opcode that fetches the code hash without requiring the EVM code to fetch all the code and hash it themselves.
So, does anyone want to advocate for that other than Nick, or have any strong opinions either way? I think it's
Nick,
something that could go in. Oh, go ahead, Lane.
Just curious, Nick, do you have an example use case, like a high-level use case where this would be useful?
Yeah, so for instance, I wrote a smart contract that is able to check another contract's bytecode for disallowed opcodes, such as store or call. And you can have multiple contracts with the same bytecode, and if you could fetch the hash, you could efficiently just record which bytecodes you've scanned in the past. But presently, it requires fetching all the code and then hashing it. Any other case where you want to check whether a contract's code corresponds to some set of known good codes that are allowed is another use case.
Yeah, that sounds useful. So, for example, whitelisting contracts for something.
Yeah, I mean, I believe there's a lot of bad reasons you might do that, but there are also some good reasons to do that. So.
Cool. And there is an Ethereum Magicians thread that talks about it more. So one thing, Nick, I think that at least on the EIP's website, there's a lot of things that are TBD. Oh, that's okay. Never mind. Those are just test cases and implementation. So that's something that would need to be done after we approve it, pretty much.
Yeah.
But maybe a little more detail in the EIP would be helpful for people to understand it more. It looks pretty straightforward, though.
Yeah, I mean, if people have specific things that are unclear, I'm very happy to expand on them.
Yep, and then I know Martin's all for it, because he said so online and in the past. And then, so Viox needs some clarification for a few things on the Magicians Forum. So if you can take a look at that, Nick, before next call, we can address those then.
Sure.
Wonderful. Any other comments on that EIP? Okay. The net gas metering for S-Store operations, we already talked about that a little bit, and Nick gave an overview. What do people think about putting this in Constantinople?
Yeah, definitely.
Yeah. To answer Alex's question just now, do any of these EIPs have impacts on scalability and sharding? So on the sharding side, basically none of them do, and that doesn't matter, especially because the sharding roadmap is kind of starting with this separate beacon chain. Skinny Create 2 makes state channels easier, and state channels are definitely a very valuable short-term scalability technology. Another thing we could do to improve scalability is we could improve scalability of privacy. And the way that we would do that is by adding an EIP that dramatically reduces the gas cost of ECAT and ECMUL and pairings, and making sure that all of the major implementations have like optimized implementations of those operations, so that doesn't introduce any kind of new any kind of new dust vulnerabilities. And I actually think that's something that probably could be valuable, right? Because like if we can knock the cost of any of these ring signature applications down from the current like 200,000 something gas per participant to something like 30,000 gas per participant, then I think we'll see a lot more like Ethereum-based privacy solutions in the short term, and we'll probably see a lot more ZK Snark stuff, and ZK Snarks can also help with short-term scaling.
Is that an EIP already?
I'm not sure. And speaking of Snarks and EIPs, I forget. Is like Blake? I know Blake too. Like I know Zuko really wanted that in there, and there's theoretically like implementations floating around. Does that? Yeah.
Sorry, Vitalik, it's Alexei here. So I just wanted to comment on the snarks, so the Ethereum-based privacy solution. So I had a chat with some people, and so they've done some benchmark about the actual putting the like a ZK snarks type transactions on Ethereum, and the main gas cost seems to be not the actual computation of EC elliptic curve signatures, but actually the storage cost of nullifiers, because they need to keep forever the registry of the nullifiers that already been spent, so that nobody can double spend them again. And that seems to be by far the major cost, not so the actual EC signatures are basically just really insignificant compared to that.
Wait, hold on. That's so the cost of a storage slot is 20,000 gas, and if it's just a matter of indices, then if you cut the size of the indices down, you can probably amortize it down to like 5,000 to 7,000 gas, and well, probably more like 7 to 10,000 gas. But the cost of verifying a snark, even with the more recent snark protocols, is still in the hundreds of thousands.
Okay, I see.
Okay. So, from all that, Vitalik, is there anything actionable that you wanted from those suggestions? Either EIPs being created, maybe looking for some EIPs that might already be out there?
I mean, I'd actually be interested in seeing people's opinions on number one, that gas cost reduction for elliptic curve math, and number two, Blake.
So I know previously we tabled the Blake 2B addition to or the Blake 2B addition to the precompiles because we were waiting for EWASM, and we were saying we didn't want to add a bunch of precompiles in the meantime because that would take away from other research development and improvements.
Okay. Well, I would argue that that the things that have changed now is like obviously number one, this roadmap by which EWASM is definitely going into the new sharding land and not like EVM 1.0 main chain, which will realistically kind of delay its availability. Number two is just that, like, given that most of the work is already done, and like in some ways it is actually lower complexity than a lot of the other EIPs because it's kind of fairly contained. I suppose it's probably, and like obviously just seeing that it's like Blake is legitimately a very fast hash function.
Okay.
Yeah, and then the elliptic curve stuff. Like I think that's like I know that there was already work on integrating a faster library for that into GEF. So like if the client's FS delivery is already, then I think cutting the gas costs down is a no-brainer.
Okay. Can someone do an EIP on that? If someone, or Vitalik, if you could do an EIP to reduce gas costs, like a simple one, I think that'd be helpful, and we can bring that up next time.
Okay.
Oh, sorry. I just remembered, Vitalik. I just remembered why I said that the storage cost was actually overwhelming the elliptic signature, because it is possible with, at least with the Starks, to actually aggregate many signatures into many basically such transactions into one, and you reduce the cost of the signature verification, but you cannot aggregate the nullifiers. So when you start aggregating, the cost of storing nullifiers becomes the main cost, essentially. Yeah, that was the context.
For us, like the cost of a snark is still like very substantial, right? So I guess the benefits are like, okay, so the benefits of having a snark, which is like cutting the gas cost of a snark by a factor of like, let's say for the sake of example, we managed to cut it from like 700,000 to 200,000. So first of all, that's a 10% scalability gain because there's still a block gas limit of 8 million. Second, it improves usability because it means that you need to wait for a smaller number of things before you publish before you can aggregate all of them and publish a snark, and that reduces the latency of the application. And so at any given like acceptable fee level, the latency of an application could potentially go down by another factor of 3. And third, I'm not just thinking of snarks. I'm also thinking of other tech where elliptic curve stuff dominates. So to give very particular examples, one is BLS signatures and like aggregated signatures and stuff in that category. Another is ring signatures and the more expanded stuff involving like Peterson commitments and range proofs and all that. And I mean, there's a lot of other fancy stuff that you can do with elliptic curves as well.
Okay. That sounds like a good argument for it. So we'll put the Blake 2B stuff on the agenda next time, and I'll let Zuko and Jay Garybird know that this is back on as a potential for going into the next hard fork. Does anyone have any other comments? I think that like Zuko and his people are willing to put some work into this to figure out some implementations that are compatible across clients. But I know they found some for Go and Rust and Python, I believe. So, yeah. Any other comments on that?
If I can derail things a little bit on the vague topic, I wanted to take people's temperature on potentially introducing other elliptic curve points, sorry, not points, curves, such as P256, which would be useful for verifying a bunch of non-blockchain stuff.
Oh, Vitalik, could you mute?
Oh, sorry. We'll mute right now.
I am detecting a lack of impassioned pleas on either side of the table there.
Yeah, that's kind of been a theme today. So, Nick, if you want to plead your case, I'll definitely include it in the list for next time.
Yeah, I mean, the really short version is obviously my particular use case is DNSSEC, where places like Cloudflare and others are starting to make P256 really widely used, but it does seem to be the curve of choice for a lot of asymmetric crypto applications outside blockchain. And it'd be really useful to be able to do like an EC verify for those curves as well.
Is there any... go ahead, Alexei.
Sorry. Yeah. So I mean, I think it's all good. But what I could the trend that I could see with these kind of things is that remember this thing about the risk architectures of the CPUs, where some people we used to have like a really processors with a really complex instructions, and some people came around and said, let's do the very simple things but very cheaply. So maybe there's a way to essentially just sort of generalize it in a very small set of instructions which could implement any of the elliptic curve. things?
Yeah, so I actually asked about this a couple of months ago, and the feedback I got was that you can't really have a generic elliptic curve library because not all curves have, like, there are certain subsets of curves that are a lot more amenable to computing than others.
But what about the general kind of field arithmetics library?
Right.
Like a finite field arithmetics library. So then you can, if you do it very cheaply, then you can implement anything you want in terms of elliptic curves.
So we do already have mod add and we do have mod mul, right? Like, I don't think that finite field arithmetic is the bottleneck. Like, I feel like it's the glue, like, even for elliptic curve implementations, it's more the glue around the finite field arithmetic that's the bottleneck, right? So, like, for example, an EC mul requires something like 500, like on average 384 elliptic curve additions. And an elliptic curve addition itself is like something like 10 field operations. So you have like basically 5,000 many thousand units of glue even within one elliptic curve multiplication. If each of those units of glue involves like 5 Ethereum opcodes, that's 10,000 times, like 50 gas, and that already gets you to 500,000. Like, I feel.
And what kind of glue is that, Vitalik? Do you know?
Basically, I mean, part of it is just like pushing and popping, and just the fact that you have to like add a bunch of like while loops.
Oh, I see. Okay.
I feel like if we, like, I'm talking here about adding precompiles, not new opcodes, and if we did so, we can, clients can potentially implement multiple curves using the same underlying library, because I know there are semi-generic ECDSA libraries that can support multiple curves. So the additional complexity per curve should be fairly minimal. It's more like adding new standard libraries than it is adding new opcodes.
Oh yeah, sorry. So I actually thought it would be a couple of codes. Yes, it makes sense for recompiles.
So is there an EIP created for this already, Nick?
There is not, because I wanted to sort of, as I say, take people's temperatures first and before I wrote something out.
Great. Well, sounds like there's not super hard opinions either way, or I actually couldn't tell. Was Vitalik's opinion dissenting or just more commenting on the overall idea of precompiles?
No, I was just making the comments that were already most of the way there to having precompiles for finite field operations. And the like basically, and like you might want to do this yourself. Like look through some like the elliptic or the contracts that I wrote that implemented elliptic curve multiplication in Serpent, and where basically a lot of memory and various glue.
Oh, Vitalik, you're cutting out.
Like that's like if we want. Yeah, and if we want to increase the efficiency of like doing elliptic curve operations, then we do need a precompile that's kind of a bit further from the middle in some way.
Okay. So, okay. Nick, if you want to... Peter, did you have a comment?
Just some minor thing that I noticed while we did the BN256 optimizations a few months back is that at least for the BN256, we have multiple opcodes, multiple precompiles, and any actual ZK snark or whatever verification will use multiple calls, multiple invocations of the same opcodes and or precompiles. And there's a really interesting issue that one thing that each and every one of those precompiles does is verify that the curve point is actually valid. And the verification is insanely expensive. And because we have multiple precompiles to create complex behavior, we actually repeat the same verification over and over and over again. I don't really have any particular point to say with this, just that it may be something we need to pay attention to.
Although, hold on, like if we try to do that, like actually compute how much point verification costs, right? that's just verification of the equation y squared equals x cubed plus b, which is possible. Like I can see how that's comparable to the cost of to the cost of an EC add, but an EC mul I expect to be much bigger than that, right? So I guess I'd agree.
So I'm not sure. As far as I know, basically it is the cost of an EC mol. Is it an EC add?
Wait, you're saying that verifying that a point is on a curve is like on the order of the cost of an EC mol?
I think, but I may be mistaken. It was a long time I looked into it.
No, that's like mathematically not possible. So if like that sounds like there's software optimization opportunities in there somewhere.
This does raise an interesting point, though, which is that people have raised in the past, which is, should we reduce the gas cost for calling precompiles? Because at the moment it has the same gas cost as calling any other account, which expects disclose.
Anybody?
I guess I'll write up an EAP for that too.
I think there is already EAP for that. I think it's written by Jordi. I just saw it today.
Oh, right.
By Jordi Balina. I think you could just find it.
Oh, that's cool. That's convenient. All right. In that case, yeah, if you could write the EAP for that, that'd be great, Nick. Any other comments on that? Specifically his the P256 elliptic curve. Okay.
Sorry, my knee-jerk reaction is adding new precompiles. I'm against it. Adjusting the gas cost of existing ones is a lot easier.
Does that mean, you're against adding precompiles full stop? Or, what sort of use case makes it compelling enough to add?
It's just the trade-off because, first it's one precompile, then it's 3 or 4 more precompiles. And one of the promises of EWASM is that, it allows permits users to deploy their own precompiles. So once you start getting into the, 3, 4, 5 more precompiles, it's probably worth looking at, deploying EWASM onto the main chain.
But, nothing we can do here will accelerate the deployment of EWASM.
But there is a bit of a trolley problem because adding new precompiles can slow down the development of EWASM.
Will it? Why?
How significantly?
Well, it would slow down the potential adoption of it on the main chain. Either you adopt EWASM on the main chain or you don't, and then you have a bunch of precompiles.
Yeah, I guess the challenge is that adding precompiles in part contributes to delaying EWASM because EWASM would also have to implement a version of the precompile, or is that not the significant thing and it's more just a matter of using resources?
Yeah, no, it's more just a matter of coordinating on what's the next, thing that's going to be adopted on the main chain.
Could add precompiles implemented in WASM, and then it will kind of make it a smoother transition to just using them as proper WASM contracts.
Yeah, that would be a good stepping stone, I think.
So explain that again real quick, Everett and Casey. What would be the stepping stone?
Well, to provide implementations of the precompiles in WebAssembly without, rather than having an implementation in Python and an implementation in Go and so forth.
Well, that's also assuming that we have a timeline for EWASM, which I think is most people's concern.
Well, we don't even have to, you don't need a timeline for EWASM to add the precompiles in WebAssembly itself, because you're going to have to implement the precompiles in some language, right? So you could, go implement them in C or in whatever, right? Or you can implement them in WebAssembly. And then it will smoothly transition to being just a normal WebAssembly or eWASM contract in the future, as opposed to if you do it in C, then the transition will be less smooth. I mean, either way, if you add precompiles now, when eWASM comes online, basically we're just going to implement those precompiles as, you know, WebAssembly contracts. And so if you do the work now to implement them in WebAssembly, I think it's going to be comparable to doing it, you know, in some other language, and it'll just be a little smoother in the future. Is that accurate, Casey?
If you implement them in WebAssembly, then every client now has to include a WASM interpreter right now, rather than when eWASM is ready. And it may even be a different WASM interpreter if changes are made between now and when eWASM launches.
Well, WASM interpreters are fairly standardized at this point. It's eWASM that is not quite nailed down. So
Right.
I think.
Doesn't that mean you could end up with a WASM interpreter and an eWASM interpreter?
Say again?
Couldn't you then end up with two VMs, one for the WASM you wrote the precompile in, and one for eWASM?
eWASM is just WASM, so.
Yeah, the goal, one of the design goals of the eWASM is to be able to use vanilla WASM interpreters.
But it would mean that each client would have to incorporate a WASM interpreter, if not a WASM JIT engine, if the gas costs are going to be low enough on the for the precompiles. But you wouldn't need to have implementations of all the precompiles, just the WASM engine.
I just don't think it's reasonable to ask clients to implement WASM VMs just for.
They don't need to implement them though. I mean, Firefox already has a WASM engine, so does Chrome, so do, I mean, there's dozens, I mean, maybe not dozens, but there's a lot of WASM.
None of our nodes run in browsers, so that's not terribly relevant.
I think you can run them separately.
I guess the main I see it as is the one of the main risks of implementing precompiles, but their semantics is not easy. Well, it could be quite complex. Whereas the semantics of the opcodes should be pretty simple. So it introduces the risk of the consensus failures, because if multiple clients, especially in different languages, use different libraries, which sometimes give you different results, then you have a potential consensus failure. And another thing I wanted to note is that currently, as Vitalik mentioned, that some part of this glue is the swapping and duping on the stack. Currently it costs 3 gas to do these operations on a stack, and I think we might see whether it's actually overpriced. Because I also saw that in Go Ethereum, for example, there is a lot of kind of cost of the stack allocation memory. Maybe that could be optimized, and we could bring the cost of this glue down somehow.
So, Alexei, I wasn't entirely clear on your stance. It sounded to me like you were arguing for precompiles in WASM, but I wasn't sure.
No, I'm just arguing that we might still find the way to implement what I was asking before. Instead of precompile, is implementing, like lowering down the cost of implementing the arbitrary elliptic curve arithmetics directly on EVM. And I wasn't talking about eWASM.
Okay. Well, in terms of consensus failures, I think precompiles implemented in WASM is worlds better than precompiles implemented as some external library that the client calls out to, because everyone has to agree on how to execute WASM anyway.
I agree, but I don't think it makes sense to try and introduce this now as opposed to when introducing any WASM VM. I don't think it's reasonable to expect clients to embed a WASM interpreter so that they can have, for the next.
I mean, we don't have to say the clients have to have an eWASM interpreter, because WASM can be compiled to LLVM, I'm pretty sure. So I mean, we can just write the contract in some language that compiles to WASM, and then have the WASM code and say this is the precompile that we agree the network will run, and then also compile it to a binary that can be linked into a C implementation, right? So it's not. I don't think we're losing that flexibility here. I think the point, though, is that we have a single, WASM contract, or a single contract in a language that we all agree on execution for, that the precompile is implemented in.
So that's an improvement, but even with that, like linking it into Go, for instance, is a non-trivial undertaking. Something like implement P256 as a precompile goes from perhaps 100 lines of code to 1,000 lines of code.
Yeah, I mean, I'm not entirely sure of the implementation cost of these things. I guess I'm just arguing for the benefits of doing the precompiles in WASM, which I think Casey has also argued for similar benefits. Another benefit is that it becomes easier to kind of decide on the gas costs of the precompiles, because you can just look at the kind of consensus implementation of it and just meter it and see what the gas cost is. But anyway, so I guess this isn't, these are just some things to consider.
Okay. So we have a few options here. We'll be talking about this more in the next meeting, definitely. The last item, which we won't even really go into that much, is Skinny Create 2. It seems like there's universal support for that. Is anyone against that? And then, yeah, because for better state channels and all that. And then I think, Peter, you had a comment in the agenda about restrictions on the execution context. Let's see if there's... Oh, is Peter gone? Peter might have had to leave. Okay, we could talk about that next time. And I think Vitalik actually gave an agenda comment that actually addressed that anyway. So yeah, we'll have Skinny Create 2 as one of the options next time. And hopefully that EIP will be a little further along so we can talk about it. Because I think it's pretty new. Vitalik, would you consider it pretty much done, or is there much more to be done with it?
Probably not much more.
Okay, cool. Then we'll bring that up next time. That's the end of the list, and we're over time already. So in 2 weeks we'll reconvene and focus a lot more on what EIPs will go into Constantinople, so we can start having a timeline developed. Thanks everybody for coming today, and any of the other stuff we talked about, let's just take it offline to the core dev chat in Gitter. Thanks everybody. Bye.
Thank you very much.
Thanks, Hudson. Thanks, guys.
Bye.